this actually works out kind of well because I kind of went through this with second hour, and I left off the tail end of it, anticipating that you guys would have had a couple more questions because I wasn't around, but that kind of backfired. So hey, you're going to have a little bit more time today than you probably anticipated to get this stuff done, which is great because I think most of second hour flew through it after we got going. Now, I know that, excuse me, I know that you guys saw law of cosines in the past, but what I want to do here is talk to you about when do you have to worry about law of sines versus the law of cosines. Law of sine versus law of cosine. Really, the only time you ever have to worry about law of sines is if you have this.
That's the same.
This is 6. It's actually its own unit. I remember what 6 is. Let's see. If you have an angle and its side opposite, you always use law of sines. Always. There's no reason to use anything else but that because, as you saw, law of sines is actually really quick because it's just fraction equal fraction. So if at any point in time you ever come across, you have the angle and you know the side length opposite, use law of sines right away. Law of cosines is when you don't. And that's about as easy as I can break it down for you. In essence, when you see law of cosine style problems, it's going to look like, I hate to fall back to the old congruent triangle stuff, but if you see either of these two setups, you will not have an angle and its side opposite. Because you'll have all three sides, or you'll have two sides and the angle in between. So if you have one of those two scenarios, it forces you to have to use the law of cosines. Once you use the law of cosine once, you will then immediately have an angle and a side opposite, which means you don't have to use it again, which is nice. Law of cosine is not difficult. It just takes a couple extra steps to work itself through. Okay. Yes, ma'am?
If you have SAS, wouldn't you just use the other formula?
No, because what I want you to remember is when you have side angle side, that means you have two angles and you have the given side between them.
So
Oh, I'm sorry.
angle.
I'm sorry. I just did angles there.
I was like,
Yeah, so you'd have that. You'd have to use law of cosines here because you have an angle, you don't know the side across from it. So this would have to be a cosine problem.
Yeah, you're talking about the side, not the area.
Correct. Yes, and that's the difference here. All right. So that's what you're looking at. So law of cosines, again, looks weird. We usually write it out 3 different ways, just so you guys get the idea of it. Law of cosines, stop drumming. The law of cosines is a relationship between an angle and its side opposite. It's trying to create that relationship. So on one side you'll have a side, the other part of the equation you'll have the angle portion. For example, one of them looks like this. Side A squared is going to equal b squared plus c squared minus 2bc cosine of angle A. Exactly. So what happens here is it looks really, really messy. But take a look at what's going on. You have a relationship between the angle and its side opposite, and the rest is just fill in the blanks. This formula, therefore, gets replicated just by switching out the b and the c values. Yes, sir?
Why can't we just use like how we have with the law of sines, where it's like cosine blank, but like cosine angle over its opposite side?
It doesn't work. It doesn't work. That won't work for it doesn't set up right because the real reason why it won't work like that is because when you're finding a cosine of an angle, you're looking at it and you haven't learned this yet. It's generating values of x that get the possible values of theta between 0 and 180 degrees. So you can play around over here in this secondary quadrant, which gives you a negative cosine value, like an angle of 150. You can take the cosine of 150 to negative something. Whereas if you're on sine values, it's going between 90 degrees and negative 90 degrees. It's looking within two different quadrants. So the reason why this has to work with this one, you can't do that other relationship, because it doesn't allow for obtuse angles in cosine, but yet in sine, the calculator inverts it and does something different. It's a whole nother ball of wax, but it's just this other formula. That's all. Does that make any sense?
Yeah.
Sure.
Okay. And if I do this again with just rotating my letters through, I just switch them out. B squared and then one more. I'll write these on the board too. Yep, it's the same formula. It's just rewritten three different ways for depending upon what side and what angles you're working with. That's all. And quite honestly, you really just need to know one of them. It's just moving letters. And from what I've understood, even we do this in regular geometry. I know I just did this a couple of weeks ago with my regular geometry class. And when I gave them the law of cosines, they're like, "Oh my God, it's awful! I can't figure it out." They were able to write it out and solve it. It wasn't that big of a deal. Okay. So what happens with law of cosines is you could be solving for one of two things. You could be solving for an angle, or you could be solving for a side. The first example I'll show you is how you solve for a side, because it's the easiest. Let me just write this out real quick. I would suggest write the formula out a couple times. You'll know it right away. Yes, ma'am.
Does it matter, like, if you have, like, c squared, it wouldn't matter if you did, like, b squared plus a squared?
No. Because this addition is commutative, multiplication is commutative. You just have to be careful when you find your terms. All right. Really, the only rule that I want you guys to remember is remember this little bit, and I know you guys do. The largest angle is always across from the longest side length, and medium to medium, small to small, and so on from there. And what I want you to do whenever you're dealing with law of cosines, if you ever have to find just an angle, if you need to find an angle, all right, let me write this. If you have side, 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 find the largest angle first. A lot of times by finding the largest angle first with the law, if you're using the law of cosines, if you get to the largest angle, and each time you always try to find the largest angle, no matter what, you alleviate the possibility of running into an ambiguous case. Doesn't mean it doesn't happen, but you kind of alleviate that. It's less of an issue, if you will. So let's do an example of finding a side length. I always think that's the easiest. That's that side angle side scenario where you've got your two sides and the included angle.
Can you go back to just a second?
1/1000. Joking, because it's funny. So smooth. We good? We good? So take a look at this one. Solve triangle ABC with little a of 12, little c of 16, and angle B of 38. Gee, what do you think we're going to do first?
Find the largest angle.
Draw it. When you fill it in, you'll notice, again, you have dun, 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 side angle side. Which means, what is it forcing you to solve for first? Can I find angle C first? What do I have to find?
B side.
B side. When I have side angle side, you're always going to find the side opposite that angle.
And then can't you use law of sines? Then?
Exactly. You only have to use law of cosines once. You can use it again if you want. It's just a pain in the neck.
Wait,
And-
so that's how you find the opposite side?
Yep. Because what happens here is you've got the angle B, you know the sides A and C, that's why you have your side angle side, and the formula allows you just to find the side opposite.
Can you do that for angles too? Or no?
Yes.
So like you could plug the angles into there and then put the sides into like the cosines.
Yeah. No. We'll rephrase that question in about 5 minutes. After I know this one, I'm going to show. I think I know where you're going. Okay. Hopmore.
So you do you use those for if it's side angle side and side side?
Yes. Because what happens here is you can solve for either the side or you can solve for the angle. And we're going to show the angle one here in a minute because that takes a little bit longer. Okay. So in this case here, all you have to do really is just direct substitution. And you will notice all you have is a whole bunch of junk that equals b squared. Throw it in the calculator. I type it into my calculator exactly the way I wrote it out, and I press this button that says enter. And I get b squared is 97 and change. How do I find b? Yes, sir?
Find the square root of the answer.
Find the square root of the answer. Very good. Second square root of my answer. And there's b. Side b is at 9.87. Okay? That gives me my value of b. So now, do I have an angle and its side opposite? Yes. As soon as I have an angle and its side opposite, I immediately switch to using law of sines. Because law of sines is quicker to do for finding angles than law of cosines. Okay? Getting there. So in this case now, I always want to try to find the next largest angle. So this one I have to find which one? C. I got to find C first. So I do my law of sines. The sine of 38 is to 9.87, as the sine of C is to 16. Which means, what do I have to do with that 16 right away? I just put it in right away. By now, you guys have probably seen a couple of these shortcuts that you can kind of get away with. So if I type that in, 16 sine 38 divided by 9.87, and I get that 0.998 and change for the cosine value of C, which means I hit my second second sine of my answer, and I get 86.41. That's my angle here for C, 86.41. Now, is that acute or obtuse? Acute. It's acute. So, what you need to check real quick is if it can have a secondary triangle. Right. So check it real quick. Remember the 180 minus 80. I know it can get long going here. You subtract that out. I did this earlier.
So there is a second
It could be.
I got room just for that.
And then that's 93.58.
So then what would you add to the 93?
You add to it the original angle you were given, which was the 38. So this is the possible C prime. You add to that your 38, which is your original A, and you get what?
41.
So that means there's a secondary triangle that you could do. Here's the deal. Here's the deal. I will not require you to look for the secondary triangle if you start with law of cosines.
I'm sorry, law of cosines every
Let me rephrase that. When you have to start with the law of cosine, okay? So if you have to use the law of sines, if you're given an angle and a side opposite, you have to use law of sines. Okay? Now, if you wind up with a, and this is one of the reasons why I wanted to start with this example as opposed to the side, side one, because I was showing you, oh, look how easy it is. You just take a square root of this and you're done. Oh, but wait. Instead of building up to that horror, I figured I'd start with the horror and work my way back. No, but I know that solving out these triangles when you have to use law of cosines, law of sines, they get to be rather tedious. And if we have if you have wind up having to do two ambiguous cases, you run out of space so fast. So if you have a side or a side angle side case for cosine, I will not require that you look for the secondary triangle. Is that fair? Let's save that for pre-calc.
Yay.
Sarah wants to do it all now.
Oh, don't worry. We've got enough stuff later on that you'll have fun with. This we're not going to worry. But do I have to finish out finding the other angle after we found angle C? You guys just subtract out and be okay, right? Yes, sir.
Is there a way to find a dead triangle?
No, because what happens is only going to be two possibles because of where when you have sine values are only posited in the two quadrants, so that's why they're reversed. It's not positive in three. Yes, sir. It's called the internet. It's March, and everything's posted.
It's not posted.
That's not posted, so I shouldn't yell at you. But if you go to the internet and you watch on the video, it is posted. It's on the calendar.
I checked it out last hour.
From last night, yeah, it was.
It was there yesterday, $12.
Not today.
Yeah, okay.
What?
Some kids, like some freshmen at lunch with us, are talking about how they found a Drags video of Christina Ryzoff singing it to him and Juan today. I was like,
That's awesome.
I was like, I know what that's for.
Oh, that's great. All right.
They found it.
Side, side, side. Side, side, side. Again, big, giant hint. Always find the largest angle first. So we have triangle ABC with little a of 8, little b of 18, little c of 13.
Find angle B.
Correct.
Wait, so this is when you have to find an angle?
Yeah, and this is where a couple people are starting to ask about what happens here. When you have this side, side, side case, what you always want to do is you always want to try to find the largest angle first. In doing that, not only the ambiguous case kind of goes away, but a lot of the other stupid mistakes that can happen go away too. And I don't want to say stupid mistakes, but what happens a lot of times with law of cosines, if you do things in different orders, because of the possibility of the ambiguous case, you could so easily get weird numbers, okay? So always use this as a general rule. Go for the biggest angle with cosines, okay? Which means which angle do I have to find? B. So I write out my formula. B squared, A squared, C squared minus 2AC cosine of B. Fill in the blanks.
This is basically like the Pythagorean theorem for non-right triangles.
Kinda. Bless you. And before you get too far into this, I want you guys to think of it this way. I want you guys to think of it like this. The equation I threw up on the board has some simplifying and combined like terms before you can do anything, correct? So if I put that up there, I have 10 equals 2 plus 5 minus 2 times 2 times 5 times x. What can you combine first of all? The 2 and the 5. So I get 10 equals 7 minus 20x. Are we okay with that? I can't write that as negative 13x, correct? Why?
Because you can't combine the x with the non.
Right, I can't combine non-like terms. So here I would subtract the 7, I'd get 3 equals negative 20 times x, divide out by the negative 20. And this would give me my value of x. Are we okay with that?
Yep.
The only thing that's different between doing that and working through this is that you've got some squares. And at the very end, when you get this value all set up to each other, you have to take the inverse to get b by itself. It really is still like a 3-step equation. It's just written differently. So when you get cosine problems, you have to find the angle. Do this. Figure out that first. What is it? 230. It's actually 221. 18 squared is 364, right? That's cool. But it's 322 or 222. Okay, so I have those two going so far, right? What's 2 times 8 times 13?
208. No, it's 222.
I didn't say it, you said it. I was refraining. What do I move next? No.
If we would have started with one, it might have actually been.
Subtract your 233.
Sarah, you're using the calculator.
And divide
Yeah.
negative.
Well, there's this kid in my
Nope,
chemistry class
that's-
who never uses the calculator.
Yep.
Oh, the guy in front of me.
Yep.
And his twin. And his brother. Oh my god.
It's because they race. Every worksheet they race each other.
So, what do you do now?
Divide by
Divide by
negative.
negative.
All right, so if you get this far, you're going to get. So right now you have some crummy decimal, 91 divided by negative 208 equals the cosine of b. How do you find b? Very good. Gives me an angle of 115.95. So I have a cosine value.
They're here. Close the blinds. An intruder.
Don't say that.
Who's here? I don't know, but they're looking at the door.
Don't say that. There's a
Hi! Come on in, you two, you crazy kids. What's going on?
Nothing if you're bored. So
Sweet, good to see you. See you.
what's the?
We're doing law cosines.
Rub it.
No, thanks. Try to quit.
Law of cosine?
That's fun.
It is. They got scared about the whole law of science ambiguous case, I think.
Oh,
So then you have angle B then is 115.94.
I didn't see. I just did law of sine.
Now what do you do? Correct. More specifically, law of science. Which angle?
Of any of them, A.
Which angle are you going to find next?
Oh, C.
We don't lie.
Use this as your pivot. Find angle C. Use law of science. I would, because did you find A first? All right. I would always try to go with the next largest angle just because it's, in this case, it won't be that big of a deal because angle B was obtuse. But if you start getting acute ones and you start messing around with it, it can get kind of messy. So,
Mr. Murphy,
yo,
I have a question.
yes ma'am.
About what age do you want to die?
Huh?
I'm just curious. Like, do you want to like live to your last day like 107, or like die early before you get too old?
I'd love to be able to retire and take care of my grandkids.
So you
So
want
I'll-
to live for long.
I'd like to, yes. I'd like to be
That's interesting.
in my mid to late 80s because I plan on.
Mid to late 80s though?
That's not that late.
Well, that's a pretty good life. I mean, if I hit 90, that'd be awesome.
Oh, so you're like, yeah, so you're guessing you're gonna die early?
I don't know.
Alright.
Yes, ma'am. That's awesome. Yes, ma'am.
My great grandmother's on my mom's side died on May 19th, 11 years ago. Both at 95.
That's my dad's birthday.
What'd you get for angle C? What is it? 40.50. Izzy, did you get her? There's so many of you now. Red hair, Izzy. Did you get 40.3 for C after you did yours? 50 points.
Sarah, you're just messing it up today.
No.
Is that our homework?
Do these 8. Make sure there's a mixture of law signs, law of cosines, and Pythagorean theorem, right triangle trig stuff.
We're done?
It's up to you to figure that out. Yeah, because I was anticipating you guys had other things and you didn't, so whatever. So this is on 8/11, 13/6.
Oh yeah, thanks for writing down a lot of the things on the board yesterday. That was very helpful.
40.5.
Did I?
Yeah,
Yeah, you have a lot of it written on the board.
Oh, I did? I didn't realize I did that.
You'd you say something and then you write it down, so like you have a chance.
You got over it. You just squint and you just imagine what I would write.
Because like we can start talking about something and we
They
go
don't know
right.
about the fridge. Why do you not tell me about it?
You know, I've been pretty bad this year about moving up on the fridge.
I put my name on the fridge.
I've been pretty bad about it. I'll get better. Next Monday I'm passing back little tests and quizzes and shit, so they can go back to the fridge.
There it is.
Sarah, come here.
Alright. I've been bad.
Hold on, I want to do math.
Come here.
What do you crazy kids like?
We're just eating. We've never been here. We look at the past. We look at the
Sarah's literally taking
Yes, you can.
Senioritis is kicked in.
We actually had plans on how much we got from yours.
That's how I did that.
Yeah.
And then, okay, yesterday.
Yeah, I'll get you one.